Okay, so now that we know a little bit about differentiation, both graphically and algebraically, we can use the knowledge to prove some helpful theorems. These are the extreme value theorem, the mean value theorem, and Rolle's theorem. The requirements for each of these are listed in the table below. This is a critical table to memorize. We know that for the extreme value theorem to be applied, the function must be continuous on the closed interval. And we see that that's true for the mean value theorem and for Rolle's theorem. In order to use the mean value theorem, the function must be differentiable on the open interval, as well as for Rolle's theorem. And Rolle's theorem has the additional requirement of my function value at A must equal my function value at B. So the requirement of continuity on the closed interval is just that. The function cannot have any discontinuities along the interval, including the endpoints. However, because it's only required that the function be differentiable on the open interval, not inclusive of the endpoints, mean value and Rolle's may be applied even when there is a sharp point at one or both of the endpoints. So this is a key point. Differentiability is not a requirement for applying the extreme value theorem. Okay, so the three theorems are outlined here. The extreme value theorem states that if a function is continuous on the closed interval, then that function must have an absolute maximum and an absolute minimum on that interval. Further, those extrema can only occur at either a critical value or an endpoint. The mean value theorem states that if a function is continuous on a closed interval and differentiable on that open interval, then the average rate of change is equal to the instantaneous rate of change for at least one point in the interval. So mathematically, that means that on at least one point on the interval a to b, f prime of c will equal to f of b minus f of a over b minus a. Rolle's theorem is a special application applied under the condition that the average rate of change on the interval is 0. It guarantees that the function must have at least one horizontal tangent in the interval. So mathematically, Rolle's theorem, when f of a equals f of b, then we know that f prime of c, there must be a point c where the derivative is equal to 0, which if you look at it from the perspective of the mean value theorem, this is still the case, but because f of b equals f of a, our numerator is equal to 0. Okay, so we need to determine if the functions below are continuous on the given interval. If so, determine the absolute extrema on that interval. So for 1a, because this is a polynomial, we know that f of x is continuous on the interval negative 1 to 2. So to determine the absolute extrema, find our derivative. So f prime of x will be 12x cubed minus 12x squared. So we're going to set this derivative equal to 0. And we have that 12x squared times x minus 1 is equal to 0. So our critical values are x equals 0 and x equals 1. And then to find the extrema, we're going to set up a table of values where we have x and f of x. We need to remember our endpoint. So negative 1 is one endpoint, then 0, 1, and then 2 is our other endpoint. And now we need to evaluate the function at each of these points. We know that when x equals negative 1, we're going to have 3 plus 4, so that's going to be 7. When x equals 0, we have 0. When x equals 1, we have 3 minus 4, so that's negative 1. And when x equals 2, go ahead and do that, so that's 3 times 16 minus 4 times 8. 48 minus 32 is going to be 16. So we can see that we have a minimum at 1, 1, and we have an absolute maximum at 216. So I want you to go ahead and find the absolute extrema for B, and then we're going to go ahead and do C. So first of all, is 2 tangent x cosine 2x continuous on the interval from 0 to 2 pi? And we know that this function is not continuous. On 0 to 2 pi, because there is a discontinuity. Tangent x has a discontinuity at pi over 2 and 3 pi over 2, which tells us that EVT does not apply. Okay, so in example 2, we want to find whether the mean value theorem applies on the interval from 1 to 4. So remember, for mean value theorem, we need to state that f of x is continuous on 1 to 4. The second is f of x is differentiable on 1 to 4. If so, find the value of c such that f prime of c is equal to f of b minus f of a over b minus a. So we have f prime of x is going to be 4 over x squared. So we know that, therefore, by MVT, there exists a c on 1 to 4 such that f prime of c is equal to f of b minus f of a all over b minus a. So now we need to find what f of b and f of c are. So f of b is going to be f of 4. So we have 5 minus 1, so that equals 4. We need f of a, which is f of 1. And we see that becomes 5 minus 4, so that equals 1. So we have that 4 over c squared is equal to 4 minus 1 over 4 minus 1, which gives us that 4 over c squared is equal to 1, or c equals plus or minus 2. However, c equals negative 2 is not in our domain, so we know that there is a value at c equals 2 such that f prime of c is equal to my average rate of change. Okay, so for example 3, we have 2 stationary patrol cars equipped with radar that are 5 miles apart on the highway. As the vehicle passes the first patrol car, its speed is clocked at 60 miles per hour. 4 minutes later, it crosses the second patrol car and is clocked at 65. Did the vehicle exceed the 70 mile an hour speed limit during those 4 minutes? So this is the mean value theorem at work. As long as there's no holes that the car could have dropped in or any points where the velocity couldn't be continuous or its position isn't continuous. So we know that the position of the car is continuous on 0 to 4 minutes. We know that the function is differentiable because the car keeps moving, so the velocity is continuous, which means that the position is differentiable on 0 to 4. We know that by the mean value theorem that x prime of c will equal to x of b minus x of a over b minus a. So x prime of c is going to equal to, so my position at time b, or 4 minutes, is going to be 5 miles. My initial position will be 0. And then I have 4 minus 0 for minutes. So this is 5/4 mile per minute. But remember, we're looking to see whether it exceeded miles per hour. So this is where, and if you've taken chemistry, dimensional analysis will come into play. So we have 5 miles in 4 minutes. We know that there are 60 minutes in 1 hour. And since we're looking for miles per hour, we can see very quickly that the average velocity, or the average velocity of the car at some point along there, the average velocity is 75 miles per hour, which means at some point between patrol car 1 and patrol car 2, the car had to go at least 75 miles per hour. So the answer to this is yes, by mean value theorem. Okay, so we need to look to see whether Rolle's theorem can be applied to the functions below on the given interval. So on the interval -3 to 3, f of x is continuous, -3 to 3. I know that f of x is differentiable on -3 to 3. So now I need to see what f of 3 is. So when I plug in 3, I have 27 over 3. So 3 cubed over 3 minus 9 is equal to 0. And f of -3 is going to be -3 cubed over 3 minus 3 times -3. So that's -9 plus 9 is equal to 0. So yes, Rolle's theorem, it can be applied. So I'd like you to find, as part of this video, what the value guaranteed by Rolle's theorem is. So now let's look at example B. F of x, is it continuous on -1 to 5? We can see that because the denominator is x, we know that f of x is not continuous on the interval -1 to 5. Therefore, Rolle's theorem does not apply. And then this last one, f of x is continuous on the interval 0 to 4, but f of x is not differentiable at x equals 2. Therefore, Rolle's theorem does not apply.